be able to come here, and so I appreciate it. And so I'm going to be given a, hold on, get rid of it. Thank you. So yeah, this is dealing off of my dissertation and some advanced work, and part of the desire for myself of giving this talk is to get pushed. As I was talking to some of the folks at lunch, is a lot of times when you're dealing with issues of equity and diversity, you can go to a conference like PMENA or something like that. The people that come into the room, I always say, like, I feel like I could go out and give everyone a hug, right? You know, it's very, they're already like buying into what this is. So what I'm looking for from this talk is to get pushed a little bit, to challenge some of the conceptions or whatever the thoughts or findings that I'm presenting here, and just to kind of make this longer. So thank you again for this opportunity. So again, this is talk about the emerging practice of teaching mathematics as agape, not agape, agape. So and we'll talk more about what that is in just a second. So we start with students, right? And so students need to have we need math. We need math for certain things, for academic and economic opportunities, right? And so sometimes some things get in the way of those things happening, right? We have achievement gaps, we have other things that interfere with that relationship. So we start thinking about, well, what does get in the way? How can we then think about facilitating that relationship? Well, we can think about having teachers, right? Teachers facilitate that relationship, that math disseminated through the teacher to the students. But sometimes, as you can see from the image, is that that's a one-way relationship sometimes. And I think Palmer talks about it as a one-dimensional relationship, or the dominant relationship of truth-giving, right? That math is disseminated to the teacher, who then disseminates to the students. There isn't that two-way relationship. There's something that might be needed to have this two-way, an interaction directly between students and mathematics. And so we start thinking about what are some progressive ways to teach mathematics. And so here's an example. I heard this on NPR once of like, hey, here's some great things that are happening with mathematics. And we think about it from a relationship standpoint. Well, first, let's go ahead and read it. We put something on the board. We gotta read it. So senior Sophie Dietz is dancing in front of a dry erase board, improving math-themed lyrics to Christmas carols. Instead of poring over those fat old textbooks and working on piles of AP practice tests, she and her classmates are learning complicated concepts like integration by parts, by making videos about them. And she says, I want the calculus to be like a scary monster, and then we being like superheroes. And so again, it sounds like, wow, they're really doing something. They're avoiding those fat old textbooks and working on piles of AP tests. They're doing something maybe that's a little more critical thinking, or they have to use some higher level thinking to come up with these videos. But then you look at that last sentence. I want the calculus to be like a scary monster, and then we being like superheroes. Well, what do superheroes do to scary monsters? They kill them, right? That doesn't seem like a very positive relationship. So taking that sort of lens and thinking about, well, what can we do? What if we started off with a relationship that's based off of love, right? Or unconditional love, agape. And again, don't worry, this isn't going to get weird, all right? Okay, so but really, let's define agape. What do we talk about when we talk about agape? And we can compare agape to something that we've talked about recently. If Valentine's Day, we talk about this idea of love of eros, right? So agape is unconditional love. Well, what is eros? Eros is a love that desires to possess. It's also a love of the worthy, right? And that's in direct contrast with agape, which is a love that seeks to give, right? And so it's given irrespective of merit. So what would that look like in a math classroom? What are we seeking to give? And again, I want to think about giving them a relationship, but we'll get into that in a second. So here's kind of where I'm going to be going throughout this talk. We're going to try to wrap up by, I know that clock's not right, but 4:30-ish, and then so give time for some questions. But really, so when thinking about the motivation, I was a classroom teacher for 5 years in a high school in a state where they like cows and cheese, right? So where I was really motivated throughout my studies and throughout my teaching to really think about, how do you improve the world through the teaching of learning of mathematics? And that then led to, well, what does teaching mathematics as agape or unconditional love look like, right? And so let's think about how I'm kind of framing that question and really think about a theoretical perspective. So again, think about this idea of mathematics and students, about building a relationship, right? And so we can think about this as becoming a more central participant in a community of practice, right? Where everyone's interacting, trying to get more in tune with what it means to be in a relationship with mathematics. And so, how does the teacher fit into that relationship, right? How does the teacher go into facilitating that relationship? So I borrowed from Magdalene Lampert's work, Teaching Problems, the Problems of Teaching, and what she called the problem space of teaching. Really kind of, it's a simplified version of the instructional triangle that we've come to know and love, that we've seen in a lot of other work. But here's, think about teaching action as proceeding simultaneously in relations with the students, in relations with the content, and the connection between the students and content, right? So that's what we call teaching practice. But then, how do we interact with this space, right? How does the teacher interact with these different relationships? And so I'm borrowing from the universal design process, which is basically used for inclusive educational purposes. So when you want to think about teaching math, we've heard about teaching math for social justice, but if we talk about teaching math with social justice, so teaching math more equitably, some things that we can draw from inclusive education would be worthwhile. So that's why I'm dealing with the universal design process that lays out, again, how we might interact with that problem space of teaching. So the universal design process, a lot like backwards design, comes up with 4 simple questions, right? So who will engage the lesson? So who are the learners, right? And the universal design process really thinks about looking at your learners from a multidimensional perspective, an asset-based perspective. A lot of times they talk about using multiple intelligence theory to look at learners, but we're just thinking about them from an asset-based perspective, right? And what content will the students engage with, right? That's a common question, right? And then how will the students engage with the content, and what will be accepted as evidence of the students' learning, so process and product. So then how does this overlap with the problem space of teaching? The students are our learners, our content is mathematics, and then we have process and product is what the teacher then puts into place in an attempt to facilitate that relationship. Now Lampert talks about students studying, right? Students are studying things all the time, and it's not necessarily the things that you want them to study, right? You can think about it, if those that have had teaching experience before. You're in a classroom and you see a student studying their phone, learning how to do emoticons in the middle of your class, right? They're studying something, they're learning something, but it's not necessarily what you want them to be learning. So an example of what a teacher might put into place could be, sometimes go into a classroom and see a geometry teacher has given a crossword puzzle of all the different vocabulary for a unit. Now that's they're engaging in the process, they're asked to produce a product, but is that necessarily giving the relationship that you want that student to have with mathematics, right? So is it necessarily facilitating the kind of relationship we want? So that's why it's different from the actual relationship between the students and mathematics. It's what we put into place in an attempt to facilitate that relationship. All right, so what I'm going to talk about next is like what the kind of relationship that I want students to have, and it can be found in this article in the JUME, which if you're looking for how to find that article, you can go to AmazonPlanet.com and find it there on that page. Fantastic. All right, moving along. So what is teaching mathematics as agape? So what I did is looked at, in order to think about what kind of relationship I wanted my students to have with mathematics, coming from a place of agape or unconditional love, this unconditional giving of a relationship. I looked at equity pedagogies and looked at, different equity pedagogies, looked for patterns within those equity pedagogies and then categorize them according to these 4 facets that I'm going to show here. Well, first, one facet to the relationship I want students to have with mathematics is functional, that students can work with mathematics to achieve success as defined by society. So this would be a functional literacy as defined by Connie North. This would also be classical mathematics and academic, she changed it. Laura Latson-Billings is one of her facets from culture relevant pedagogy, but classical knowledge from Rico Gutstein. They kind of fall into this idea of a functional relationship with mathematics. Basically, can you get through the doors you want to get through mathematics? Can you pass your standards-based tests? Can you get in, pass those placement exams? Can you get the grades that you need to get into school? Functional relationship. Ooh, we don't want to get online. Okay. See, it wanted me to go to Facebook. That's probably it. Next, we want a communal relationship with mathematics. The students can work with mathematics in and with the context and practices of the students and the students' communities, right? So what are the students bringing to the classroom? And where is that classroom located? What can be used as assets within, within that space in order to, again, facilitate a relationship with mathematics? Can they, as Rochelle Gutierrez talks about, can mathematics be seen as both a window and a mirror, right? Can they see themselves in the mathematics, and can they use mathematics to see the world, right? Well then, if you're going to have that, sorry, I'm supposed to pick up my daughter. There we go. I'm going to be late. So basically, if we have this foundation here, so a functional and communal relationship with mathematics, I mean, we could stop there, right? But if all we're doing is, you know, if we assume that there are, well, if we understand that there are gaps, if there are achievement gaps, if there's something wrong with the system that we keep producing some inequities, well, if all we do is produce students that are capable of going into that same system, we're just going to be replicating some of those inequities. So we also want to create some change agents, right? So another facet of the relationship is a critical relationship. So this is dealing with you know, the critical facet from socio-political consciousness, from cultural pedagogy. This is critical literacy from County North. This is critical knowledge from Rico Gutstein. So that students can work with mathematics to analyze and question the world. There are problems in the world. If we are looking at our community, if we're using our community from that communal facet, we're gonna, if we're looking at, we're gonna see problems, we're gonna see issues, we're gonna see context that we can then, that we're passionate about, that we can then use as fuel, again, to facilitate that relationship with mathematics. And again, a lot of the times that's dealing with the problems and issues that, that emerge from a community. But the thing is, there's one other facet that I believe is necessary, because if we're going to, if we're thinking about facilitating a relationship between students and mathematics, if every time that I hang out, well, let's say Ryan, if every time I hang out with Ryan, all he does is bring up problem after problem after problem, and just issues, and they're just, you know, kind of these soul-crushing things. I don't want to hang out with Ryan much more, right? So the thing about that with mathematics, and the thing about this critical perspective, is that it needs to be balanced with something, right? So we talked about an inspirational facet. The students can work with mathematics to vision and progress toward a better world. And this is seen really as a visionary literacy with from Connie North, where she talks about, you know, how can you keep moving forward? How can you keep recognizing that there is, you know, positive things, if even though that, you know, things right now aren't that great, right? Okay. So if this is the target for the type of relationship, well then, okay, well how do we make that happen? How do we facilitate that sort of relationship with mathematics? Well, that was interesting to me. So I wanted to see what it looked like. So kind of what I just explained to you is what I see as what teaching math as Agape might look like in theory. So then, you know, if you have a theory and you're been a math teacher for 5 years, you want to see like, hey, what does it look like in practice? So that's what I went and took a look at. And so here's some quick methodology here. Did self-study, one class for every day for an entire semester. And the methods, you know, basically in a rural high school, again in a state that likes cheese and cows. Using the Core Plus curriculum, which I think is actually was a big asset in doing this sort of type of teaching, in the fact that it was integrated. It allowed for mixing up of different, it allowed, well, basically it's based on context, so it allowed for replacing context. We'll get into why that's important a little bit later. And I was, also what was helpful was I was a field test teacher for the Course 1 and Course 2, which allowed for just being fairly familiar with the content. And it was an integrated math course, which was an inclusive course. This was a single track within a high school, so there was, you know, students, a very heterogeneous representative sample of the freshman class within this course. And I didn't want to have, it was important to me to not have a separate, you know, section of students. I'm trying to take over a set of students that any teacher would have to kind of, I know it is was kind of unrealistic, you know, only having to teach one class, but it was, I just wanted to have a class that was, again, representative of the students within the school. So participants had 20 students, myself, the cooperating teacher, it was basically the teacher of record, and then an assistant principal who I identified as critical friends within my self-study. Data generated, I was just talking to Kevin about some limitations of data. Wisconsin IRB were #1 in protecting students. No video available, just from a power standpoint. Even though I wasn't the teacher of record, they would not allow video at all. So we deal with what we have. And so thinking about again the data, we have lots of class periods, lots of journals. I did this for one semester, 14 student journals, and then we have the assignments, some of the assessments, and some classwork that they did as well. All right. And finally, data analysis using NVivo, Excel, that sort of thing. And engage in cycles of coding. This is where I thought it got a little bit interesting with regards to basically what I saw within the data from the study. So in zero cycle, we talk about it as initial coding. They're taken off from the data. The first cycle was based on the framework and facets of the relationship implied by teaching math as agape, or what you call provisional coding. And what was interesting is thinking about my code, and I just didn't put this up here to think about, so you can see all the codes, but to think about this, the frame that I was using to look at my classroom kind of changed how there was a play back and forth between how I was looking at it and then what that meant for my analysis. For instance, come up to this situation within my notes where students were cheating. They're cheating, they're copying on each other. It happens, right? And I was trying to think well, what does that mean? And obviously as a teacher, you're upset by that. But then you think from the frame, if they're trying to, what are they trying to achieve, right? And basically, the cheating was students working with students to try and achieve a functional relationship with mathematics. Now, it didn't mean that they understood the mathematics, but if they get the grades that they want, they're trying to achieve something, a grade, right, in order to move them forward in society. Now, we know that that's limited because they won't have the actual conceptual knowledge to pass additional courses on that, but they're trying to do that. So it basically made me think that I was missing something, right? That these students working with students was missing within my within the framework there, right? So we added that on. And so basically this is kind of feeling like how it all filled in. We can ask questions about this later if it's interesting to you. But I will go into more a little bit on this. So basically fill that out. We're looking at where throughout the semester did these things, did each of these codes fall into place. And that led into some patterns. And the patterns we'll get into in just a second. And then the 2 cycles, merging of these two. So what was interesting, so taking off from the data with what matched up with the provisional code, looking for patterns, and then seeing what shook out from there. And so here we go with what the findings are. So turning was an emerging practice of, excuse me, read that for a second. Turning was an emerging practice of teaching math as agape, which we described was defined as the manipulation of disruptions in teaching practice and opportunities to facilitate the relationship between students and mathematics. So taking these seemingly bumps in the road, and how do we, again, turn them back into facilitation exercises, or facilitating of that relationship. So for example, this socialization turned a learning asset, right? So one of the things that was emerged from the journal was, so during the experiment, I noticed Grace tell Rory that she liked her boots. It was at a time when both groups were paused for action. I asked Grace if I could use that instance as an example tomorrow. I want the class to know that I want them to be social, that I know that they need to be social, but I want them to pick appropriate times to do it. So in this case, we're looking at, I know that they're adolescents, know that they're teenagers, know that they need to be social. You do that, right? But let's separate that from actually doing the of the mathematics. And you see this is early on in the semester. Then moving on to, again, think about, how to facilitate that relationship. I want students to practice articulating their thinking. They have a strength in being social. I want them to use it while working with mathematics. So moving it from, I'm thinking of it as a distraction, we need to feed the beast a little bit, go ahead and take care of that, but then come back to mathematics to instead, no, that is something that is going to help again, create that relationship between students and mathematics, right? And so we see that as, so students working with students are socializing, they're building on building their communal practices of being teenagers, right? And then, so we think about, how do I get, that's my relationship with them, there's a shift in perception, so now we deal with more cooperative processes and products, right? So this even goes into, I've never given a test or a quiz, I give celebrations of learning. Again, nothing but fun, all hugs in my class. But what this kind of realization led to was doing more some group-based celebrations where you have higher anxiety, right? Higher anxiety to do well on a celebration, on a test or a quiz, right? And students are more willing to learn and concentrate, so that actually tones down on the social, outside socializing, that they're actually using those skills and abilities to talk to each other, ask questions. And so, again, more cooperative processes and products emerge from this kind of shift that, hey, these friendships, these connections that students have, these are to be used as assets in facilitating that relationship. Right? Turning disrupted lecture to a lesson structure. So this is a little bit similar. So basically, it got to be that a time of the year where they're just the honeymoon's over, right? They want to stop listening to you. You're not just like not laughing at the jokes. They're just kind of they want to talk to each other. They want to get into being together. They didn't want to hear what any instructions I had, even though I had very limited instruction. So this led to an upset teacher. I was upset. So I'm journaling about it and thinking about, okay, what do we do? What do we do? They don't want to listen to me. They want to listen to each other. So one of the things we did at the beginning of the year was these leadership inventories. And I knew that in my classroom I had several what I'll call lions, right? Lion leaders, right? They're more the take charge kind of leaders rather than the stand back and encourage sort of leaders, right? So using those assets within the classroom, we then led into a lesson structure where the bell rings, they lead the lesson, right? They go back, they know the instructions, they know what exactly sort of tasks we're supposed to engage with. They go in and they start leading that task on their own, right, without my engagement. So again, we see that socializing aspect, lots of socializing going on. They're communicating to me, hey, we don't like hearing from you, we dislike this lesson format. And so now we take on the knowledge of that, take that knowledge of the student leadership styles, and again, we put that into place as a lesson structure in order to facilitate a functional communal relationship with mathematics. And I was even thinking about this, possibly even on inspirational, in the fact that they could have some impact on the world, but we can leave that one alone. Finally, let's get into some more mathematics. So disgruntled students leading into investigation. So basically, this was, I thought I had a picture of this, but basically one of the students, so I have celebrations, and if you're going to have a celebration, you have to have an invitation. You have to have an invitation to a celebration, or else how are you going to know, right? So they have, every time we're going to have a test or a quiz, they have an invitation. And on the invitation, it talks about, well, just like with any celebration, you got to say when it is, what do you need, right? And so they're told on their invitation what is going to be on the celebration, the objectives we're going to cover, when it's going to be. And then we give some process questions, right? How are you going to prepare for the celebration? How have you done on your practice? We don't have homework either, we have practice, right? And so we talk about those things. And then at the bottom it says, do you have any questions? Any questions? So one of the students, and this was kind of echoed throughout other interactions with students within the week before this, was why do we have so much effing homework? He didn't say effing. You spelled it out nice and clear. My students did like me. They did. It was fun. And basically, that was, again, echoed. And you kind of hear this rumbling going on. So the students were, and we'll get into this, the students were working together and always in this questioning the amount of homework, right? Over and over again. It's, why do we have so much homework? We have homework every night. Oh my goodness, so much homework. And again, I'm like, I'm not giving you homework. I'm giving you practice. But they said, hey, why do we have so much homework? So I'm seeing that they're questioning the world, right? They're working with each other. And so let's take advantage of this. Let's lead into an investigation. Well, we did, and given the knowledge of the objectives, in that unit we had a data analysis unit, and so we said, well, let's collect some data. And we made an investigation exploring the amount of time spent on homework where, I think I have an example, here we go. They collected some data and they looked at, okay, given the typical freshman, and again, they're a representative sample of the freshman class, so we looked at, well, what kind of homework, amounts of homework do they have? And this led to some interesting revelations about not only just finding the things that they need to do. So I think you can see the objectives there. Use various graphical displays to plot data, interpret patterns seen in graphical displays, compute, interpret measures of center and variability for sets of data. They were able to take this and do those things with it. But now, if you're looking at the data, and you all are mathematical, you might start asking more questions about the data. So what questions, let's have some interaction. What questions do you have about the data that you see? And you probably have the same questions that my students have.
What was the one kid doing for a minute for gym class?
Exactly, yes, all right. What's 1 minute of gym homework, right? What else?
Well, the opposite spectrum, what's 2 hours of biology homework and 2
Yeah.
hours of history homework?
You're right, yeah, that same student, 2 hours of biology, 2 hours of history, okay? And so, not only did the students start, and I think that another one did 2 hours of history, maybe they did it together. Another student did 2 hours of history. And we started talking about, well, what about the truth, let's use a word, truthiness of the data, right? And what do we know, and what happens when now we're going to talk about what do these big numbers mean? These big numbers are thrown off our measures of center. What do we do when we take those out? Now they're doing stuff in advance. This was in course 1. They're doing stuff that we're not even going to do till course 2, but the questions are coming up. So they're advancing beyond the objectives that we wanted them to based off of the data that they've collected, that they're invested in. And one of the things, and I don't have the question, the prompt on here, but the end result of this was to come up with a conclusion. Like, do we have too much homework? If we come up with the conclusion that we have too much homework, we'll take a look at it. And basically, they came up with the conclusion that we're doing just fine in math class, and we need to talk to that history right? But again, it was a way for, okay, so this and maybe in years past I might have just tried to just say, like, you don't have that much homework, you do fine. But why don't we use that disruption and practice? Okay, let's use it. Let's use it as fuel again to facilitate the relationship with students and mathematics, right? And this turning, this example of turning here, I think is also another example of another emerging practice of teaching math as agape, which I'm been calling deviating, right? So taking off from the curriculum is written to facilitate the intended relationship between students and mathematics. So turning is taking disruptions of practice and again funneling back towards this facilitation, right? But deviating is something I think that you can be ready for. And what I mean by deviating is you have knowledge of the, and I think okay, so I'll leave that up for now. So this is one that been re-looking at my data and thinking about what did it mean to deviate, right? So if this example was deviating, there was a knowledge of the content and knowing that, well, this investigation could easily be replaced with another data set, right? So now we have a data set of them investigating the amount of time they spent doing homework, right? So before I even started teaching, I was preparing to I didn't really think about it. I thought I was just looking for context that would be easily replaceable. But I looked through the curriculum and tried to find places where it would be easy to replace context, right? Within the curriculum that was written. Again, Core Plus, it's full of context, but then think about, okay, what would be an easy things to replace? And I'll show you an example of that in just a second. But also, too, was being knowledgeable of the existing kind of teaching math for social justice lessons out there as well. And being knowledgeable of those, and then how could I use those existing lessons to teach the content that I've been assigned to teach. Now, I think this is important because some of you that are maybe familiar with teaching mathematics for social justice, the work of Rico Gutstein and Tanya Bartel talks about teaching math for social justice. The Rethinking Mathematics book is full of teaching math for social justice tasks on radicalmath.org, I believe is a packet of lessons on teaching math for social justice. And you see a lot of the same things that I'm going to show you here. But what a lot of the criticisms of those is that they miss the math, right? They might be really heavy on the context, and the math might fall short. And I'll give you an example. Rico Gutstein even talks about this one, School Boundaries Project. Basically, the school district that he was a part of was going to change. Where am I doing on time, Ryan?
35.
Okay.
You're good.
You done fine. Was going to change the boundaries of the district and basically changing the makeup of who was going to go to the district, right? Changing the proportions of students. They had a Latino population and an African American population within the school district. And basically by redrawing the boundaries, they were going to basically reallocate those proportions. So this came up at a school board meeting on Monday. On Tuesday, boom, they jumped into it, right? They jumped into looking at these proportions and what they would mean mathematically. And he even admits in there that they missed the mark a little bit on the mathematics. They did get a chance to look at the issues with using mathematics as a tool, but they feel like they might have missed the mark on the math. And so my feeling is that I can't afford that, right? I've got students that need to pass their No Child Left Behind test. I can't play around with their knowledge. I can't play around with their functional relationship with mathematics, right? That's something that the cooperating teacher who I'm accountable to needs to be reassured that I'm going to take care of that. So basically becoming knowledgeable about those potential lessons, but also becoming knowledgeable about the opportunities for deviation within my own curriculum, I think allowed me to be prepared to deviate and deviate well. So again, identifying opportunities for deviation. Here's an example. So here's a problem, very appropriate, Daytona 500, just finished a few hours ago. But the NASCAR, talking about the Daytona 500, and basically it's an inverse variation. Basically a situation where you have an increasing rate of speed and want to say like, well, what does that mean for the time, right? So we just need a nice little inverse variation curve. And basically this is from the first unit in course 1, which I like to call an algebra buffet. It's just basically the objectives were recognize important patterns, exponential, linear, inverse variation, quadratic, use graphs, tables, equations, and words to describe those patterns, and answer questions using those representations about those patterns. Okay? Real simple objectives. But basically, this one is the inverse variation exploration problem. Right? So this became a star in the book as I was going through and looking for opportunities to deviate or problems where this could be an easy context to replace. Just need a constant with an increasing rate, right? And so this became an opportunity where at that same time, the students were in their social studies class, and they were talking about current issues every day. And at this time is when the BP oil spill was happening. And you remember how that occurred? And it was like, oh, yeah, there's an explosion, there's some oil leaking, but it's 50 barrels a day, right? It's just, that's it. Okay, well, and then the next day it's like, yeah, it's 500. And the next day after that, it's 1,000, right? And then it keeps going up and up and up. And the kids become like, oh my, like, have you seen this? They don't even know how to estimate this stuff. And so we have this increasing rate. Now we just need a constant. And so we use something that they were talking about in the current issues class, comparing this disaster to the Exxon Valdez. And so now, there we go, we've got a constant. We've got the 750,000 barrels of oil that were estimated to be spilled from the Exxon Valdez in Alaska. And then we have this number of barrels per day in thousands of barrels, right? That were being that were leaking out of the oil well in the Gulf, right? So what did this mean for how fast it would reach that 750,000 barrels? And again, able to explore that same pattern of, hey, there's a closer to zero, you're going to have a bigger change with a unit of 5 versus later on a unit of 5 is going to give you not much of a change in the number of days it's going to take to meet that $750,000. But again, able to deviate, take advantage of a of a situation that's occurring and able to get them to think about the world as it's occurring around them, right? And so one of the things you might be asking is about, and that's one example. Another example was students had a lack of, very soon after the school year started, one of our students, alumni, was killed in Afghanistan. And our students really understand that that wasn't the first person from the community that was killed in Afghanistan. And so we started looking at the cost of war. Now, in that Rethinking Mathematics book, cost of war is a lesson that was prepared, that they used and looked at, and that somebody else had created and prepared. So we took that same lesson, use it in at the end of this actually algebra buffet unit, and was able to think about what is the cost of war, not only in the cost of monetary dollars, which was the aim of the unit, but also in the cost to a community, right? What does it mean that your physical education teacher has to go over to Afghanistan for a tour, and that you don't even get a chance to interact with that student, or that same teacher's family misses them? Like, what is the cost beyond just monetary cost to cost of a community, right? And so getting them to build up some empathy and thinking about issues that they might not normally think of. Right? So what is it dealing with student relationships? So I did some things, and just like that student relationship, this is just sort of a fun thing. But had them, hey, if math is your friend on Facebook, was a word or two that you would use to describe your relationship status with mathematics. And it's just a little bit interesting, so this is an initial one. It said single. I choose those words because I'm not good at math, and math is boring to me. I don't know, I'm pretty sure that's about being boring. Relationship status, enemies, because I don't like math and I'm not good at it. Okay, now, the thing that I noticed about these two is that they're talking about this innate ability to do mathematics, and that they don't have it. Okay, I'm not good at math, right? I'm not good at, I do not have this like genetic condition to do mathematics, right? And then so we go on, and we see very good, because I'm finally feeling like I'm understanding the next unit very, very well. I'm just loving understanding this unit. And then horrible, we're working on spelling, because I don't understand it. If I understood it, I would like it. And so you're like, well, it's, 1 out of 2 ain't bad, right? But other thing to notice is that there's a shift, and now we're not talking about I have the genetic condition. It's, do I understand? It's about understanding, right? It's about having that understanding of someone else, right? And trying to figure them out. And so even the other one, the horrible one, wrote this one first, right? It's changed because I like what we're doing in math right now. I understand it. It's easy. I think it's fun what we're doing right now, and I like to do it on my own and understand it. So it's not I don't have the genetic condition. It's the horrible one. It's about not understanding it, right? And here it is about understanding. So like there's a path laid that relationship can be a positive one, right? If we can help the student have some understanding, versus I'm never going to understand that. I don't have the condition to understand. I don't have the condition to do, or the genetic condition to do mathematics, right? And so, I'm going to stop here. Am I forcing? So I'm not in a classroom anymore. I'm teaching teachers, but I've been working with teachers and asking questions and thinking about what kind of relationship do they want to have with mathematics. I think naming a target, not necessarily, this is my target, and the teachers might not necessarily name this specific target for themselves, but having a target and thinking about what kind of relationship do I want to have with mathematics. If it was a productive way for me to think about my teaching as I was engaged in the process, and I think it might be productive for them as well as I work with them. So, I'll stop there.
All right.
There you go.
Thanks, Joel.
Thank you.
Do you guys have questions for Joel? You got about 15 minutes.
I have one question. These 4 categories, I don't know if I should call it categories actually. The functional, communal, and critical, and inspirational.
Yeah, the
Are
facets.
they,
The facets, yeah.
right, are these facets like inclusive? Like if I'm teaching at the inspirational facet, I'm actually including the other 3 facets? Or it's something that I have to, they are independent from each other?
I don't think they're necessarily independent, but I think they can be independent from each other. Like, an inspirational, I could think like, oh, math is, I could see how math can, the use of math can change the world, right? So like, I can see that and have that relationship, even though I might not be engaging with math that's going to help me have like a functional relationship. I believe, yeah, so I believe that they are independent. They can be independent of each other. Yeah.
Yeah, so you noted several aspects of the course, but I was wondering, do you have an intuition or did you see evidence for or which part of that course you felt made the students go from feeling that it was genetic that was causing them trouble in math and just the fact that understanding it was what they didn't like about it?
Thank you. It's set up perfectly. So one thing I didn't talk about, but is there was a whole way that I changed of how I dealt with summative assessment, math tests, right? And so thinking about if there's one thing that most interferes with my students' relationship with math, it's that. It's the math test, right? So we do call it celebration. I wear a Hawaiian shirt. We sing, we have music, we was good times. But on top of that, we did the invitation, right? And so like a lot of these things are cute and fun, but I think behind it there's some thought about how do we best prepare them for what are the objectives? What's going to be on there? This is exactly what's going to be on it. You know that's all. You're going to know you know how to do these things. You have understanding of them. All I'm looking for is how you demonstrate your understanding. So when they would do their celebration, I would align every question on the celebration with one of those objectives. And then after going through and grading them, I would grade each of those questions on a rubric, 5-scale rubric, that basically, very simple rubric. 5 meant yes, you should demonstrate an understanding. 4, yes, but there's some issues. 3, maybe. Okay, no, but, and then no, and then 0 is no response. But it just basically became this universal language that we could use. So like, how are you demonstrating that you understand to me? And then even when a kid says, well, I don't know anything, well, great, I need to know that. Okay, I need to know that because that means I'm not doing so hot as a teacher. I need to go back and revisit those objectives. And then I would have one-on-one conferences with a student because I think, again, thinking about what's going to interfere with that relationship. If I go in and lay down Ryan's test in front of him, it's got a big red F on it, okay? Or,
No, that's far
you gotta
right.
feel
That's
it.
far
Yeah,
right.
okay. If he's going to get that, now I've lost him, right? But I could sit down with Ryan, and let's say it's out of 20. We're looking at 4 objectives, each on a rubric of 5. We sit down and show, hey Ryan, you showed, you recognized linear functions. You got a 5 on that. You were able to represent them in graphs, tables, equations, and words. You got a 5 on that. You know what? On the other ones, you got, you didn't even try on. So now you got a 10, right? 10 out of 20. Okay. So now I can say like he leaves there saying, wow, I showed understanding, and I need to work. I know where I need to put my emphasis on. And so that, I think, was a big part because everything was about showing understanding. I mean, to have a kid that gets a 12 and they got, let's see, what would be a 12? 2 4s and 2 2s, okay? And they're smiling when they leave. And we also have a chance to interact, like, hey, what's been interfering? Like, how come you don't get this? Or like, even to talk about my interpretation of their response. It, I think, led to this kind of universal, this culture of talking about understanding over and over again. Like, how are you demonstrating understanding?
So that sounds like a very, for you at least, I'm sure many people have a very important aspect of this type of program. But I don't see how that fits into one of those 4 categories well. I mean, it almost seems like it should be a 5th category. I mean,
Like a 5th, like.
I mean, it sounded like you put a big emphasis on students' attitude towards math as being an objective. It might just be misinterpreting you. But. So the way I interpret you is that those were sort of your 4 objectives, and you're describing ways in which you would achieve those objectives. I'm not criticizing.
No. This is again.
But yeah, it seemed like at least what you emphasize now was attitude, and that seems important. I just didn't see how it fit in with your paradigm.
I mean, I get with when I'm talking about those specific objectives. I'm thinking about how can they. I am thinking about more that functional, that coin of the realm, the functional relationship.
So the bottom left quadrant?
Yeah.
Okay.
And like that's, that is what we're seeing as valuable. I'm unfortunately, that's pretty emphasizing. Yeah.
So I guess to follow up on your point, I thought what you just described is inspirational, or added. In other words, I thought in my head, oh, that's a part of being inspirational, or part of what adding it up calls being a productive attitude about mathematics from that experience. That's where I put it immediately. So I guess I didn't have as much trouble as John did about thinking about that as a goal. Maybe I was wrong.
Yeah, that makes
Yeah.
sense.
Yeah.
Sure.
No, when I think, like, so we think about like the standards for mathematical practice, right? Number one, you know, if we want them people to understand problems further and solving them, like if we have kids that can do that, like that is, you know, that inspirational, right? That yeah, this is a problem I can see in front of me. I have an unknown way of solving this task, and I can go about it. And I'm gonna keep going until I get it right. Yeah, I can see that as inspirational as well. That's good. But that's good. Thank you for your question.
So one thing I kept looking for in your talk was I noticed that you made two aspects very clear, and one was that your kind of driving force is sort of the heart.
Yeah.
Your objective is the things inside the heart. But what I don't think you made as explicit, but you talked about is sort of how you would functionally get to those objectives. And one thing you just talked about, changing the way they think about evaluation. And the other one I noticed was you tended to find things that would normally be viewed as obstacles and see how they could be utilized productively. I was wondering if you thought about like the other primary functions. The reason I asked this is because I think it might be useful to transfer what you refer to as agape, which is my categories as motivational. How would you transfer that into being more functional? As in technique-oriented that could be more reproduced, because different people might have,
Right.
For one example, different definitions of agape. I'm sure you have a specific definition.
Right, and I think that is important. And like I said, I'm not going to put that onto a teacher and say like shoot for this, right? But part of it is having. I think the productive nature is having some sort of target, like, and that was my thing throughout the brief semester, right? It was only a semester, and thinking about what does this actually look like in practice. And I think something shook out, but you know, it'd be more interesting to see like if I had a full year, if I could keep going with it and think about it more and more. What does this mean? And keep going. Like, how am I facilitating this desired relationship with mathematics? And like think about, yeah, what does that actually look like in function, right? What does that look like with assessment? What does that look like with lesson planning? What does that look like with the moods of being a teacher, right? And so, and part of it is too about, I just observed Kevin's class and thinking about how, and actually seeing Kevin's class, and then I'm going to Amy's conference tomorrow, and seeing like how groups work together, right? Be more in tune with group dynamics, and thinking about how to nurture those, because I think that in that space and facilitating those spaces where they have these small group interactions is where that this sort of relationship is going to be fostered, not through my putting it upon them, right? So how do we put this DNA into the students within those groups?
Okay.
And like that's what excites me, and thinking about how do I go about doing it. And that's a question I'm going to keep working towards.
If you have other questions for Joel, we can convene down in the large conference room. There are people outside. I just saw the instructor give me the evil eye.
Oh, no.
Teaching here, so we need to go. But let's thank Joel for his presentation.
I was thinking some cookies still on.